Combined cycle power generation.
Assalamualaikum. Today I'll be talking about a very important topic in modern power system. It is a combined cycle power generation. And my name is Arina Husna and I will be present together with my group members, Nurul Izzati and Arina and Muhammad Dinish Iskandar. So, what is a combined cycle power generation? It is a method of generating electricity by combining two different power cycles in one system. First, the gas turbine cycle. Second, the steam turbine cycle. In a normal power plant, a gas turbine burns fuel like natural gas to produce electricity. But this process also produces a lot of exhaust gas, which usually goes to waste. This setup uses waste heat from the gas turbine to make extra electricity. Then they help reduce pollution and support the move to clean energy. Combined cycle power plant can reach efficiency level of up to 60% or more, while regular power plants are usually around 35% to 40%.
Assalamualaikum, I'm Arina binti Dasril. Now, I will explain the basic construction of a combined cycle power plant which uses two thermodynamic cycles to generate electricity more efficiently. This is a schematic diagram of a combined cycle power plant. The plant is mainly made up of two cycles, the Brayton cycle, which includes the gas turbine section, and the Rankine cycle, which involves the steam turbine section. Let's start with the Brayton cycle on the left. First, air is taken in through the air intake. It is compressed in the compressor. Then it enters the combustor where it mixes with fuel and is burned. The hot combustion gases expand through the gas turbine, generating mechanical power and driving the generator to produce electricity. But instead of wasting the hot exhaust gas, we recover it. That hot exhaust gas goes into a component called the heat recovery steam generator or HRSG. This device captures the remaining heat from the exhaust gas and uses it to produce steam. The steam then flows through the steam turbine, which is part of the Rankine cycle. So, in the Rankine cycle, the steam turbine expands the steam, generating more mechanical energy and turning the same or another generator. After passing through the turbine, the steam enters the condenser where it is cooled and turned back into the water. The water is then pumped back into the HRSG by the feed water pump, completing the cycle. So, in summary, the Brayton cycle generates power from the combustion products of the fuel, and the Rankine cycle generates additional power with operated by the steam generated by HRSG from the heat content of the exhaust gases leaving the gas turbine. Now that we have seen the basic construction, let's take a closer look at the key components that make up a combined cycle power plant. Each of these parts plays an essential role in ensuring efficient energy conversion. Let's begin with the gas turbine first. Its main function is to convert natural gas or fuel into mechanical energy. It consists of three main sections. First is the compressor, which compresses incoming air. Second one is the combustor, where compressed air is mixed with fuel and burned. And the third one is the power turbine, which expands the hot gases and produce mechanical power to drive a generator. Next, we have the steam turbine. This component extracts energy from high pressure, high temperature steam to rotate the shaft and produce mechanical work. The amount of energy it can extract depends on the enthalpy drop across the turbine. Enthalpy is influenced by the steam's temperature and pressure at the inlet and outlet. A Mollier diagram is typically used to calculate how much energy can be obtained. These turbines come in various sizes from a few kilowatts to over 1000 megawatts. Now to the heat recovery steam generator or HRSG. It's positioned downstream of the gas turbine exhaust. Its job is to capture the waste heat from the exhaust and use it to turn water into the steam. Inside the HRSG, there are three key sections that we need to know. The first one is the atomizer, which preheats the feed water. The second one is the evaporator, which boils the water into steam. And the third one is the superheater, which increases the steam temperature for better turbine performance. Okay, after the steam leaves the turbine, it moves to the condenser and cooling system. The condenser cools the steam using water or air. This converts the steam back into liquid or condensate, which is then reused in the HRSG, making the system more sustainable. Finally, we have the feed water pumping system and auxiliary equipment. This system recycles the condensed water and sends it back to the HRSG. It also includes various support systems such as piping, valve, control systems, and containment structures to ensure smooth and safe plant operation. So, together, these components form an integrated system where waste heat is never wasted. It is recovered, recycled, and converted into more power. This is the brilliance behind the efficiency of combined cycle power plants.
Okay, now I will explain in detail regarding operation or basic principle how a combined cycle power plant produce electricity. There are two processes or two cycles that includes in this principle, which is the first one is the gas turbine processes and the second one is the steam turbine processes. For the next slide, I will present or show you how it works or how it operates. Combined cycle technology enables power plants to generate 50% more electricity from its fuel than with a conventional single cycle power system. Under this dual phase system, two combustion turbine generators operate in conjunction with two heat recovery steam generators and a steam turbine generator. In the first cycle, fuel is burned and the resulting combustion gases power two turbine generators to produce electricity. Hot exhaust, normally lost during this process, is captured and routed through the two heat recovery steam generators. These units boils water to create steam which spins an additional turbine generator and produces more electricity. Finally, the steam is discharged into a condenser which returns the steam to its liquid state for recycling.
Hi, Assalamualaikum. My name is Nurizati binti Mohammed. I will continue with example of power generation site. Okay, the first one is at the Pulau Indah power plant located in Selangor. It uses a combined cycle system, which means combined gas and steam turbine to produce electricity. The plant has capacity of 1,200 megawatt and use a natural gas which help reduce pollution compared to coal. It started operating in 2024 and supplies clean energy to meet the high electricity demand in Klang Valley. Okay, next. Second example is the Kapal Power Plant, also located in Selangor. It is Malaysia's second largest thermal power station with a total capacity of 2,200 megawatt. What makes it special is its ability to use three types of fuel: coal, gas, and oil, making it flexible. The plant plays a key role in supporting the national grid and committed to reducing environmental impact. It also serves as a local example of how large-scale energy production can balance efficiency and sustainability. The last example is the Nishi Nagoya power plant located in Japan. It uses a combined cycle system. This plant is one of the most efficient in the world with a thermal efficiency of 63%. It helps reduce pollution and support clean energy production. As a power plant outside Malaysia, it serves as a great example of how advanced technology can improve energy generation. The last part for our presentation is the reference of our group use to find information about combined cycle power. Okay, that's all from our group. Thank you.